Hello guys, here's another episode of Java Game Development. On the last episode, we started on the framework that we're going to be building our games upon. And in this episode, I'll go a little bit in depth into some of the things that we did. If you recall, we make our game screen runnable so we can run it in a thread. You probably already know what a thread is, but if you don't or just need a quick recap, a thread is simply a path of procedures your program takes from point A to point B. There are two types of threads. Your main thread, which automatically executes what's in your main method at the start of your program, and then you have threads that take in runnable objects as their parameters. An easy way to think of threads is like a line at a bank. The people in this line are like methods of your program. They have things to do, whether it be withdraw, deposit, or have a nice chat with the teller. Even rob the bank. Doesn't matter. Anyways, they can't all go at the same time. They have to go in the order that they arrived in or the order you placed them in your method. So when you make your own thread and pass it a runnable object, it executes everything in that object's run method as a separate thread when a call is made to that thread's start method. So now you have two lines at the bank, but there is still only one teller. So these guys have to take turns going. Now sometimes there's variables that methods from different threads have to use. Those variables are represented here by nice comfy chairs. Let's say if both guy A and B get tired and want to take a break, they both can't use the same seat at the same time. If they try to, very bad things will happen. Similarly, if two methods try to use the same variable at the same time, your program can't come to a halt, even break. Technically, you can have an infinite number of threads running at any given time, but when it comes to managing variables, it gets very complicated the more threads you have. Moving on now. On our game screen, we don't extend any aught or string component. Instead, we render everything using a graphics 2D object. Now, to put this in a real-world perspective, imagine having an awesome idea for a drawing you want to show people by displaying it on the wall. Now, you can draw it directly on the wall if you like gel and stuff, or you can get a really nice piece of paper or cardboard to draw it on, and then hang that piece of paper on the wall. It looks nice now and you won't get in trouble for it. If we put two and two together, we see that our hypothetical drawing is the graphics object in our game screen class, the piece of paper is our canvas object we make in our game window class, and the wall we put it all in is our J-frame, which is extended in our game window class. So the way we draw on our canvas object from our game screen's graphics object is by creating a buffer strategy with our canvas, then passing that into our game screen object. Then we get the graphics to draw on from the buffer strategy inside the game screen object. The way the buffer strategy works is via a method called page flipping. In this method of buffering, one of the two buffers we created is used for drawing while the other one is displaying on the screen. They alternate back and forth with each other each cycle of our game loop. There is ways to buffer your game without a buffer strategy, but doing so is like trying to reinvent the wheel. I understand doing for the sake of learning, but as long as you know how buffering works, why not just use the best option, which is the buffer strategy? Hopefully I was clear and you guys could understand what I was trying to explain. If I missed anything or you just have a question, please leave a comment below and I'll take a look at it. Don't forget to take those extra 2 seconds to like and subscribe. Hope you guys enjoyed and I'll see you guys next time.